Hello everyone, welcome to online study tutorial on applied hydraulics. So today we are discussing module 1 model analysis and similitude. In this class we are discussing what is model analysis, what are the advantages of model analysis, what is similitude and its types. So let us see the introduction first. What is model analysis? So we'll go one by one. So model is basically used to predict the performance of an hydraulic structure. So we have hydraulic structures like dams, reservoir, and also hydraulic missions. So to predict the performance of those hydraulic structure before actually constructing, so we are going to test those hydraulic structure by creating a model. So that is the purpose of model. So models are nothing but those are the structure which are used to predict the performance of a actual hydraulic structure before constructing it. And also it is nothing but it is a model is a small scale replica of an actual structure, and the size of this model may be exactly equal to the actual structure, or it may be a smaller scale also. Okay, and there is no particular restriction like the size of the model should be only smaller. Okay, and also the prototype is nothing but the actual structure. Okay, so what is model analysis, by the way? See, the study of models of an actual a machine or actual structure is called model analysis. So we are going to do a test on the models. Okay, so whatever the prototype is there, so we are going to prepare a model of that prototype. So just for example, if you take a dam, so you're going to do a model of that particular dam, and we are going to do a test on that model, so that will initial itself we can predict how the dam will perform. So that is nothing but the model analysis. The study of models of an actual machine or a structure is called model analysis, and this is one of the experimental method of finding solution for a complex problem. Okay, so it is one of the experimental method, because actually you are going to test the model. So it is an experimental method of finding solutions for the complex engineering problem. So what are the advantages, by the way? See, you can predict the performance in advance. So means before constructing the structure itself, you'll get to know how the structure will perform. So that is one of the advantage, and also the merits of alternative design can be predicted, because once you test the model there, you'll get what are the merits and what are the demerits, so that whether any the design need to be altered, or is there any alternate design is required. So that is also you came to know in the earlier stage itself, and also you can adopt most economical and safe design. So you'll also get to know whether the design which we have done, is it safe, and also is it economical. So that is also can be obtained, that information also can be obtained from the model analysis, that is by testing the model. So those are the advantages of this model analysis. So next topic you have the similitude. So what is similitude? So it is nothing but the similarity between model and a prototype. So what does the similarity mean? So what type of similarity it is? The properties. So the properties of the model and prototype should be similar. Okay, so the properties means you have different properties like geometric, kinematic, and dynamic properties. So based on that, we are going to classify the types of similarities as geometric similarity, kinematic similarity, and dynamic similarity. So basically similarity means, so the properties of both model and prototype should be similar. So that is nothing but similitude. So first type is geometric similarity. So what is geometric similarity now? See, geometry represents your length, breadth, diameter, area, volume. So all those terms are the geometry of the structure. So the ratio of all the corresponding dimensions for both model and prototype should be same. So that is nothing but geometric similarity. So if you want to say, so if for a geometric similarity, so to be existed, then the ratio of corresponding linear dimensions should be same for both model and prototype. For example, if we take LP, okay, so BP, DP, and AP, VP are the length, breadth, diameter, area, and volume of prototype. Similarly, so if we take LM, BM, and DM, okay, so and AM and VM. So those are the dimension, the length, breadth, diameter, area, and volume of model. So the ratio of these linear dimensions, that is length of a model to the length of prototype, or the width of the model to the width of prototype, should be same. That is, all the ratios of linear dimensions should be same. That is equal to dm by dt. So where all these are represented by LR, which is called linear scale ratio. So for a geometric similarity, so there should be a linear scale ratio. That is nothing but the ratios of the linear dimensions of both model and prototype should be same. That is said to be a geometric similarity. So the next type, you have the kinematic similarity, which is nothing but, see, kinematic means the motion. So we can say the similarity of motion between model and prototype is kinematic similarity. So when we are going to say there is a kinematic similarity between model and prototype, so that is, see, the kinematic, see, this velocity and acceleration, those are the terms represent the motion of a structure or any body. So the ratio of velocity and acceleration at the same corresponding point, okay, both in the model and prototype, should be equal. For example, so if you consider this is a model and this is a prototype, so for example, you consider this is a model and this is a prototype. So if you are measuring the velocity at this particular point, okay, so velocity at this particular point, so this is a VP, and on the same point you have to measure the velocity of model also. Okay, so the points which you're going to select should also be same on both model and prototype. So that is nothing but the ratio of velocity of a model to the velocity of prototype. So for example, if it is corresponding to 0.1, this is 0.1. So if you take, so of same point should be same. So that is called as velocity scale ratio, which is denoted as VR. So similarly, so acceleration of a model to the acceleration of prototype on the same point should be equal, which is called as, so, acceleration scale ratio. Okay, so this is about the kinematic similarity. So the last type of similarity is a dynamic similarity. See, dynamic represents a word force. So we can say similarity of force between model and prototype is the nothing but dynamic similarity. So the ratio of forces acting at corresponding points of both model and prototype should be equal. So we have different types of forces which acts on a actual structure, like inertia force, viscous force, gravity force. So all those different forces are there. So the ratio of the, for example, if we take an inertia force, which is denoted as Fy, so the ratio of inertia force of a model to the inertia force of prototype should be equal. So that is denoted as Fr. Okay, so that is force scale ratio. So that is nothing but the dynamic similarity, the ratios of forces acting on the corresponding point. So same as that of the velocity and acceleration. So forces also you have to, for example, if you take a dam, so this is a model if you considered, and the actual structure is this, which is a prototype. Okay, so if you are measuring the force on this particular point, on the same point only you have to measure the force on the model also. So on the both the corresponding points, same corresponding point, so the ratio of forces which are acting on the model and prototype should be equal. So that is nothing but the dynamic similarity. So after this, you have different types of forces like inertia force, gravity force, viscous force, pressure force, so and surface tension forces. So all these are the different types of forces which are acting on the structure. And sometimes there may be only one force may be acting, or sometimes the combination of forces may also be acting, like inertia with gravity, and inertia with viscous, and inertia with pressure, and the pressure with surface tension, viscous with elastic force. So like that, there may be a on the actual structure, there may be a single force may be acting, or there may be a combination of one or two forces. Okay, so which is denoted Fy, that is the inertia force is denoted as Fy, gravity as Fg, and viscous force as Fe, pressure force as Fp, and surface tension force as Fs, and elastic force as Fe. So these are the different forces which are acting on the structure. See, what is inertia force now? See, the inertia force, that is Fy, is equal to the product of mass into acceleration of the flowing fluid, and this inertia force will be acts in the direction opposite to the direction of acceleration, like so if this is a force, that if this is acceleration, so force will be like this, the opposite to the direction of acceleration. So this inertia force will be there. So the second one is the gravity force. So what is gravity force? See, it is the product of mass into acceleration due to gravity, that is G. Okay, so only that is the difference. So that is whatever the fluid which is flowing by the action of gravity. So it is product of mass into acceleration due to gravity of the flowing fluid. And so you can see this particular inertia force in all the fluid problems, whereas this gravity force you can see in a open channel flows. Okay, so you can see this gravity force more in the open channel flows. And the viscous force, so what is viscous force? Then it is equal to the viscosity. So viscosity, due to the viscosity, there will be obviously there will be shear stresses is going to develop. So it will be equal to the product of shear stress in due to the viscosity. So stress is going to develop due to the viscosity, that is shear stress, into surface area of the flow. Okay, so the viscous force is shear stress into surface area of the flow. So that is the viscous force. And here, see, this is present in the fluid flow problems where viscosity is having an important role. So where you can find the more viscosity, and in that particular case you can see this viscous force. And similarly, the next force you have the pressure force. So it is nothing but the intensity of pressure. So intensity of pressure into the cross sectional area. So pressure force is, I think you have already studied in the XM also. So that is fluid mechanics. So pressure force Fp is equal to the product of intensity of pressure into the cross sectional area of the flowing fluid. So this pressure force you can see in a pipe flow, because in a pipe the the fluid will be the water will be flowing with a very high pressure. So this pressure force you can see in the pipe flow. And similarly, the next force is surface tension force, so which is equal to the product of surface tension, which is denoted with sigma, into the length of surface of the flowing fluid. So because surface tension force will be occurring throughout the length of the flowing fluid, so surface tension force Fs is equal to sigma into L, that is surface tension into the length of the flowing fluid. And the last type of force which acts on the structure is the elastic force, which is equal to the product of elastic stresses into the area of the flowing fluid. So it is elastic stress into area. Okay, so that is the elastic force. So these are the different types of forces which acts on the actual structure. So the next topic you have that is a dimensionless number, which is also called as the non-dimensional parameter. Okay, so what is dimensionless number then? See, the dimensionless number is nothing but, so it is, when you divide one force with respect to other force, for example, when you divide inertia force with the gravity force, or inertia with viscous force, or inertia with pressure force, so whatever the ratio you're going to get, so that will be as in called as a dimensionless number. So the dimensionless number is a number which is obtained by dividing any two forces. So it is the ratio of one force to the other force. So we have different types of the dimensionless number which are important. So that is Reynolds number, Frost number, Euler's number, and Weber's number. So this is a Weber's number and Mach number. Okay. So let us just discuss in detail all these dimensionless number. So what is Reynolds number then? See, Reynolds number is the ratio of inertia force to the gravity force. So which is denoted as Re. Sorry, that is Reynolds number is denoted with Re symbol. So it is the ratio of inertia force with the viscous force. Inertia force with the viscous force. Whereas a Frost number is the ratio of inertia, that is, so the Frost number, so Reynolds number is Ref, it is the ratio of inertia to the viscous, whereas the Frost number, which is denoted as Fi, okay, so it is the square root of ratio of inertia to the gravity force. So whereas the ratio of inertia to the gravity force is your Frost number, that is Fi, or Fe. We can say Fe, the Frost number is Fe. Okay, so Fe is equal to square root of Fi divided by Fg. And similarly, the next Euler's number, which is denoted as Eu, okay, so which is the square root of ratio of inertia to the pressure force, that is square root of Fi divided by Fp. And the next number, that is Weber's number, so which is the ratio of, which is denoted by We, so which is the ratio of F square root of Fi divided by Fs, that is inertia to the surface tension force. So the last one is Mach number denoted by M, okay, so which is equal to square root of Fi, the remaining force, which is the remaining force, that is elastic force. So inertia to the elastic force is your Mach number. So these are the different the dimensionless numbers what you have. So which is also called as non-dimensional parameter. So first one, Reynolds, Frost, Euler's, Weber's, and Mach. So Reynolds number is denoted by Re, which is the ratio of inertia to the viscous force, and Frost number is denoted by Fe, which is square root of Fi by Fg, that is inertia to the gravity, and Euler's number, that is Eu, which is the square root of Fi divided by Fp, that is inertia to the pressure, and the Weber's number, so which is denoted as We, which is the square root of ratio of inertia to the surface tension force, and the last number, that is Mach number, so denoted by M, which is equal to square root of inertia to the elastic force. So these are the different dimensionless numbers. So the next topic we'll just see in the next class. Thank you all.